All right, 1.1.3, we have another quadratic, but now we have a quadratic inequality. In this quadratic inequality, we are supposed to solve for x again. So 1.1.3, we have a quadratic inequality which is minus x squared minus x plus 2. So now we have less than 0. So now it's no longer equal to 0, but it's less or equal to 0. So how do we solve for x whenever we have a quadratic inequality, especially that looks like this one? So just like when we're solving normal quadratics, we will factorize again. For it to be easy for us to factorize this, let us divide everything with a negative 1 so that we will have the coefficient of the leading term as a positive. So we will divide everything with a negative 1, negative 1. Here we divided negative 1 as well. We divide with a negative 1. But one thing we should know when we are dealing with inequalities, whenever you divide with a negative, the sign changes. So this one will change direction to the opposite. So it will be greater or equal to. So now when we divide minus x squared with a negative 1, we will have a positive x squared. And then when you divide minus x with a negative 1, we will have a positive x, because you're dividing a negative with a negative. And then now with the positive 2, when you divide it with a negative 1, we will get a minus 2. So then a sign looks like that. And then when you divide a 0 with a negative 1, obviously it's still a 0. So the next step is we factorize. So now it's easy for us to factorize because the leading term has a positive coefficient. So we use two brackets. We will have an x here and also an x here. And then here we have to find the factors of 2. Factors of 2, we have only 1 and the 2. So with the factors that we use, they should give us an answer of negative 2, which is this one, when we multiply them. So that means one of them has to be negative. Also, when we add these two factors, they have to give us an answer of positive 1, which is the coefficient of this x. So which of these has to be negative? The 1 has to be negative. Why? Because when you multiply the negative 1 and the 2, obviously you will get a negative 2. But also when you add negative 1 and 2, you get a positive 1, which is the coefficient of x. So here we will have minus 1, and here we will have plus 2, greater or equal to 0. So now we have factorized. Now let us draw our graph. First, you have to determine how your graph will look. How do you determine how your graph will look? You determine it with the value of a. The value of a, if the value of a is positive, the graph will look like this. But if the value of a is negative, your graph will look like this. It will be downward facing. Some say it's set. The value of a is the coefficient of x squared. As you know, here we have the coefficient of x squared, which is usually symbolized as a, and then the coefficient of x, which is usually symbolized by b, and then the constant, which is usually symbolized by c. So when a is positive, the graph looks like this, or it smiles. So our graph will look like this. So we don't know where the values, where it meets the x-axis. So let us determine the values where it meets the x-axis. We'll do it like this. X minus 1, which is this one, equal to 0. Or these are not your answers, because at the end of the day we will have to erase this. So here we will have x plus 2 equal to 0. And then you make x the subject of the formula. So here x will be equal to a positive 1. And here x will be equal to a negative 2. So that means here we will have this negative 2 and this will be the positive 1. Let us erase this, because now we know the points of the graph, or the coordinates of the graph, or the the x-intercepts of the graph. Okay, the question requires us to determine where the graph, this one, is greater or equal to 0. 0 is the x-axis. So where is the graph greater than the x-axis? It's here and here. That's where the graph is greater. So that means our answers should look like this. The graph is greater or equal to 0 when x is less or equal to negative 2. Or the graph is also greater or equal to 0 when x is greater or equal to 1, or a positive 1. So that is just how we solve quadratic inequalities. Up next, we have 1.1.4.